This video explains the different available scaling modes of the SoundCam. The SoundCam has three scaling modes: the auto mode, the smart mode, and the off mode. In the auto mode, the focus is always on the loudest sound source in the picture. For this time point, the loudest sound source is located at the bottom of the picture and has 41.2 dB. This value is set as the maximum value of the scale by the software. The dynamic range determines how much below this value is still visible. At the moment, the dynamic range is set to 3 dB, so the lower limit is 41.2 dB minus 3 dB dynamic range equals 38.2 dB. This procedure is performed for each image. When we jump to another point in time, the software automatically detects the loudest sound source and focuses on it. This is very clear when I move through the measurement. I can use the dynamic range to adjust how much is visible below the loudest sound source. When I set the dynamic range large, I see a lot of the signal. However, you will also see a very colorful image which is not very focused. When I want to be focused on the loudest source, I set a small dynamic range. If there is no sound source in the picture, the background noise becomes visible in the auto mode. In smart mode, the background noise is filtered. When I go to the time point where sound source is visible, the source is also visible in smart mode. Since we don't know the true value of the background noise, we estimate its value. The acoustic picture consists of a number of pixels, each of which is assigned a sound pressure level. The average of the sound pressure values of all pixels is our estimated background noise. Let's go into details how the smart mode works. The curve of the estimated background noise could look like this. In smart mode, we want to stay above this curve. With the crest factor, we set the distance to the background noise we want to keep. The dynamic threshold is a curve that has the same curve as the background noise, but with the crest factor as an offset to the background noise. The smart mode sets the maximum value to the dynamic threshold, or if a larger maximum value is found in the image, to this maximum value. As an example, here are 5 sources drawn in the image. The source Q1 is visible if the dynamic range is sufficiently large. Since the source Q1 has a smaller value than the dynamic threshold, the maximum for the scaling is set to the dynamic threshold, and from there the dynamic range is displayed. In this case, the dynamic range is sufficient to display the source Q1. For the sound source Q2, the picture is different. Here, the value of the sound source is smaller than the dynamic threshold 2, so the focus is on the dynamic threshold again. However, the sound source Q2 is not in the dynamic range, so it is not visible in the picture. In the next case, the sound source Q3 has a larger value than the dynamic threshold, so the focus is on the sound source Q3. From there, the dynamic range is shown, so that the sound source Q3 is visible. However, the dynamic range is not sufficient to display Q4. In the last case, the sound source Q5 has a higher value than the dynamic threshold, so the focus is placed on it. In this example, the sound sources Q1, Q3 and Q5 are visible. Q2 and Q4 are not visible. Q4 can be made visible by increasing the dynamic range. This is also possible for Q2. Alternatively, the crest factor can be reduced for Q2 to make the sound source Q2 visible. Here you have two possibilities to make the sound source visible. What does this mean in practice? Let's have a look at our example data in the SoundCam software. By increasing the crest factor, the dynamic threshold curve is moved upwards. If the crest factor is increased too much, the sound sources are no longer visible. This is of course not wanted. If I decrease the crest factor too much, it can happen that the dynamic thresholds are too close to the background noise, and the background noise becomes visible again. Remember, our background noise is only an estimation, since we don't know the true value. So the crest factor has to be chosen accordingly to the environmental conditions. With the dynamic range, I can adjust how much of the signal is visible. If I choose a high crest factor again, so that my sound source is not visible, I can counteract this by increasing the dynamic range. Dynamic range and crest factor have to be weighted against each other and adjusted accordingly. In off mode, the maximum value can be set manually. When I change to the off mode from the stored measurement file, the maximum value is automatically selected from the measurement file and focused on it. Now I can look at the measurement file and automatically see at which points in time the maximum value or the maximum values are reached. This way I can really focus on the loudest sound source of my total measurement in time and see where the most energy was radiated during this time. This is especially suitable for making comparative measurements, for example, before and after comparisons or comparison of two different component types.